Okay, so determine the resistance of 1200 meters of copper cable having a diameter of 12 millimeters if the resistivity of copper is 1.7 times 10 raised to the power negative 8 ohms meter. You are once again welcome to my channel. So this is the example 7 of the calculations that falls under resistance and resistivity. And the question is, determine the resistance of 1200 meters of copper cable having a diameter of 12 millimeters if the resistivity of copper is 1.7 times 10 raised to the power negative 8 ohms meter. Please make sure you subscribe to the channel. Okay, so let's write our data down. So we have length, which is equal to 1200 meters. We have diameter D, which is equal to 12 millimeters. And then resistivity, which is the rho, is equal to 1.7 times 10 raised to the power negative 8 ohm meter. So we are to determine what the resistance of the copper cable. So before we move on with the solution, let's first calculate the cross-sectional area A. Okay, and we know that A, which is the cross-sectional area, is equal to what? Pi r squared. But the question didn't provide the radius. Rather, we were being given what? Diameter. Okay, a diameter of 12 millimeter square. All right. So to find the radius, we divide the diameter by 2. That is 12 divided by 2 to get radius. Okay, so we have 12 divided by 2 squared. That is 12 divided by 2 is the radius square, pi r square. 12 divided by 2 square. So 12 divided by 2 is now our radius square. I hope you're following it. Okay, so we have 36 pi times 10 raised to the power negative 6 meters squared. When we divide 12 by 2, we get 6. So 6 squared will give us what? 36. So A equals pi r squared is now what? 36 pi times 10 raised to the power negative 6 meters squared. I hope you are following it. Okay, so when you multiply 36 by pi is 3.142. So when you multiply 36 by pi, we are going to get what? 113 times 10 raised to the power negative 6 meters squared. Okay, so our cross-sectional area A is 113 times 10 raised to the power negative 6 meters squared. So let's move on with the solution now. We know that R, which is the resistance, is equal to what? Rho L over area. Rho is the resistivity, L is length, A is what? Area. So R equals rho L over area. Okay, so let's substitute the values now. So we have 1.7 times 10 raised to the power negative 8 ohm meter being our rho, that is the resistivity, multiplying 1200, which is the length, all over the cross-sectional area that we just calculated, which is what? 113 times 10 raised to the power negative 6 meters squared. I hope you are following it. Okay, so when you multiply 1.7 times 10 raised to the power negative 8 by 1200, and then you divide it by 113 times 10 raised to the power negative 6, we are going to get what? So when you multiply 1.7 times 10 raised to the power negative 6 by 1200, we are going to get what? 2040 times 10 raised to the power negative 8 all over 113 times 10 raised to the power negative 6. So when you divide 2040 times 10 raised to the power negative 8 by 113 times 10 raised to the power negative 6, we are going to get what? 0.180 ohms. So our resistance R is equal to what? 0.180 ohms. Thanks so much for watching.